Now, this tool is going to let us look at series where the plus and minus signs don't come in some nice order. Here, let's look at the sum of all the fractions where the numerator is the cosine of the integer n, and the denominator is n squared. Well, sometimes my cosine function is going to be positive, and sometimes my cosine function is going to be negative, but the cosine function is periodic where its period is 2 pi. It's an irrational number. So I don't actually know in general when is cosine of n going to be positive, when is cosine of n going to be negative. So this slide here is saying that we've got positive, negative, 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 then 3 positive, but then after that it just doesn't not repeat in a useful pattern. So I'm going to put absolute values on this and ask, is this series absolutely convergent? So to check for absolute convergence, I've got the absolute value of the cosine of n all on n squared. But since n squared is already positive, that's the same as asking for just the absolute value of the cosine function, all on n. Now, we can use the comparison test on this. Cosine of n in absolute value is always less than or equal to 1. So I can very easily compare this to a p-series. Again, this 1 on n squared. I know that the sum of all the 1 on n squared fractions converges. So that means that the sum of all of my fractions absolute value of cosine of n, all on n squared, that also converges. So my original series is absolutely convergent. And since absolute convergence gives me convergence, then this converges to some limit.